Geothermal was a topic that we discussed only briefly in class. I found it relatively interesting, but we didn't go very in-depth on it. So I decided to do a bit of research on the parts that are advantageous about it, the parts that are disadvantageous about it, but more importantly to what I found interesting was the different kinds of geothermal energy that exist today and the ones that are currently being developed. So I'm going to share with you some of the findings that I had about that. Overall, there are about 4 different types of geothermal electricity. There are 3 that are currently used and some being developed currently. The 3 current types are dry stream, flash steam, and binary cycle. And the 2 future possibilities are co-production and enhanced geological systems. The first type of geothermal plant is the dry steam plant. The dry steam plant requires a reservoir that is already in the gaseous phase. It takes that gas out of the ground, runs it through a turbine, and pumps it back. Because it's already in a gaseous phase, it doesn't even require a pump to remove the liquid or the fluid from the reservoir. While this might be the most efficient possible geothermal plant, the problem is that there are very few places that can actually support it. There are only 2 known in the US, one of which is Old Faithful. Therefore, there's only one real site that can support this technology in the United States. The second type of geothermal plant is the flash steam plant. While this plant doesn't require the reservoir to be in the gaseous phase, it still requires a very hot reservoir. The temperature must be at least 360 degrees Fahrenheit. Because the fluid is actually in the liquid phase, it has to be pumped up and flashed in order to produce vapor. That steam is sent through a turbine, and the remaining liquid is pumped back into the ground. This is actually the most common type of geothermal plant. The final current geothermal plant strategy is the binary cycle plant. This plant doesn't require the temperature to be as large as the steam plants do. In fact, the temperature can range from 225 degrees Fahrenheit to 360 degrees Fahrenheit, significantly less than a flash steam plant requires. The big difference is that the working fluid, the fluid that actually goes through the turbine, is no longer the water from the reservoir. Instead, the reservoir water's heat is transferred to the working fluid via a heat exchanger. That working fluid is usually a volatile organic, such that it can more easily power the turbine. While this is probably the least efficient technology, it can be applied in many more locations. Further, there is absolutely no risk of emissions being released from underground because the loop itself is closed. There are 2 major projects for future possibilities. Co-production at oil wells is the first one. Hot water is a natural byproduct of oil drilling process. That water is currently used is simply waste. However, it certainly has the potential to be used in a binary cycle geothermal plant. Meanwhile, enhanced geothermal systems take a different strategy. They recognize that there are dry rock, hot places spread very commonly around the world. By pumping water into that, they can use that source of heat to heat the water and create essentially a man-made reservoir. That man-made reservoir can then be used with a binary cycle geothermal plant.